sense that the engineering company is ready to accept them as an employee in their organization.
In addition with our technical classroom training, we are providing industrial visits, like we are going to outdoor solar PV plants and substations and switchgear panel visits, and based on the permissions we are getting, we will also visit various power plants. Coming to the civil people, like we will visit various construction sites.
We try to understand every person's or an engineer's abilities and then work on their efficiencies and to the core segments and help them to get placed in a right career in all aspects.
I used to work in residential field as a technical supervisor in maintenance department. I worked 3 years in maintenance. Then I decided to upgrade my knowledge in the core. Then I got to know about the HIW doing great job for the engineers who wants to settle in the core. I trained from the HIW and good knowledge in core. I got placement in Accutronic India Private Limited as a service engineer. I am very happy with my role and company thanks to HIW.
We conduct various mock interviews during the training. Based on the company profile, we separately train the candidates on interview segment, like what kind of questions they may ask you during the interview, and so that will help them in boosting their candidates' confidence. That's how HIW students are excelling in the interviews.
At HIW, we were given personal assistance, and every week mock interviews were conducted, and which helped me in cracking interviews at a very early stage, and I'm very happy with HIW.
Thank you to HIW for getting me that opportunity.
I'm very much glad that HIW is celebrating its 12th anniversary. I wish many more to come. Thank you, HIW.
HIW is the one-stop solution for the engineering grads to get your dream jobs and to upskill your knowledge. Join with HIW, get skilled, get hired.
Hi, good morning to all of you. So guys, am I audible to all of you? Yes. So before going to start the session, let me introduce myself. My name is Madan Mohan. I am the Managing Director of HIW Empowering Engineers Private Limited, holding 18 years of experience into various electrical domains, starting from switchgear panel design, substation design, solar PV plant, and oil and gas segments. So this today's free webinar, you have to follow some rules and regulations before getting into this content. Actually, the first point is if you hold the calculator, scientific calculator, then it will be better because we have to do various sizing calculations for various applications. So I need answers from you. Like I will ask the questions, you have to calculate and give me the answers. So that could be appreciated. That is one thing. And the second thing is like the participation certificate. The workshop participation certificate will be given to the candidates who fill the feedback. So feedback form will be given in the chat box at the end of the session. So you please continue with the session, and if you have any doubts, you can unmute yourself and you can ask your doubts, you can clear your doubts. Okay. And if you don't want to interrupt the session, then you can note down the points, and end of the session, I will give you time so that we can discuss. So whoever attending 2 days workshop, today and tomorrow, okay, those people are going to get the certificate. Hope this is very clear to all of you. So as you know, guys, like our topic is cable selection and sizing. I just want to get into, before going to get into the sizing calculations, first I want to make you understand the importance of this topic first, like where exactly we use cables, and what type of cables we use, and what is the importance of cables. Okay, you take any segment, you take it could be a substation, or it could be a power plant, it could be a solar, or any industry, or any like shopping malls, shopping complexes, anywhere, cable plays a vital role in feeding power to the loads. So let me start taking you from the basics to the extreme level of cable sizing. Like I will explain you each and every aspect of cable selection and sizing, guys. So you please make a note of all the points that could be more helpful for your career, because being an electrical engineer, you go any interview, there would be minimum 3 to 4 questions from the cable side. There are few topics in electrical engineering. People ask you common questions on cable selection and sizing, and current transformer, potential transformer, transformer selection. These are the bare minimum topics people ask in the interviews. So by keeping that in view, because as you know very well, HIW is intended to support electrical graduates to make industry ready. That is the major intent of HIW. HIW stands for Hyderabad Institute of Electrical Engineers. So by keeping that in view, to make you people industry ready, I'm just trying to give a glimpse on cable selection and sizing. So we'll start that now. So here, so guys, I just want to know how many of you are passed out in this session? How many of you are already completed your BTech, like a 2023, 2022 or 2024 people? Can you just say yes in the chat box? passed out guys. Pawan Kumar, Yashasvi. Good, good. Okay, nice. So considerable amount of people are there in this session, whoever is passed out. And this is also very important. See, this is not like I'm not just pointing out only passed out, like even existing engineering grads, students also, pursuing students also, it will be very important. So let's start the session. I'll just get into the topic now. So it is like a cable selection and sizing. So before going to understand the sizing methodology, you could have said this is a cable. Like first you should know what is cable. Cable is defined as the conductor with insulation. Like with bare conductor, generally we use bare conductors for the transmission line applications. And conductor with insulation, we call it as a cable. Okay, so generally there are multiple applications of the cable. Generally, we have three types of cables in the industrial applications. If you look at like based on applications, we have like power cables, control cables, and instrumentation cables. These are the three types of cables we use for the industrial applications. So now I will do one thing. I just want to make you understand the importance of cable sizing calculation first. Then I'll just come back on this topic now. Okay. So here I'll just show you one SLD. SLD stands for single line diagram. SLD is the first and foremost deliverable in electrical system. So this is one, I'll just zoom it. Here, we are now working on one project of 220 kV substation. So this is the ACDB, signal line diagram, AC auxiliary supply and distribution diagram. Okay, so here, this is the SLD, like in 220 kV substation, we are going to feed power to all the auxiliary loads. So your auxiliary loads starts from ACDB. This is a transformer. This is a transformer here. So the transformer is like a 33 by 433 kV. That is like a 33 by 415 volts transformer with the 315 kVA is the transformer capacity, and DYN11 is the vector group of the transformer. So these are the transformer's technical specifications. From transformer, we are connecting to ACDB. I'll just brief you this SLD. This is whatever this blue line indicated. This is called ACDB. ACDB is nothing but AC distribution board. This is ACDB. So from we have like two transformers we have. From two transformers, we are connecting to ACDB through, this is a cable, like two runs of 3-core 300 square mm aluminum XLPE cable. So this is from auxiliary transformer to the ACDB, and here this is a DG, diesel generator, because every power plant, every substation, we keep DG as a backup supply. So from DG, it is connected through AMF panel. AMF is nothing but auto manual functioning panel. And from DG to ACDB, also it is connected with the, sorry guys, I think this is like a 3-core 95 square mm aluminum XLPE armored cable it is. So this is an incoming cable and this is a feeder, and here these are all the outgoing cables. This is just a minute. Yeah, this is depends upon the depends upon the connected feeder. Like this is here we are going to connect switchyard ELDB. ELDB is nothing but emergency lighting distribution board. The connected load is 2.7 kilowatt. Connected load is 2.7 kilowatt. For 2.7 kilowatt load, we have connected with the 4-core 16 square mm aluminum XLPE cable. So the point here is, if depends upon the connected load, for which load you are connecting, what is the application of the load. Based on that, yeah, I know like this is not visible clearly, but I'll show you other SLD also. Tomorrow while doing the sizing calculations, I'll come up with a clear SLD. Don't worry guys. I just want to make you understand the importance of cable selection and what sort of cables we are using. And this is a single line diagram. And here, this is the sizing calculation document. So in this sizing calculation document, it is mentioned here, like this is 33 by 220 kV pooling substation switchyard LT cable sizing calculation. This is how we generally use the documents. We'll make, this is the Excel sheet we prepared for the cable sizing calculation. So guys, it is mentioned here. Okay. Like from station transformer 1 to ACDB, we are using cable. We are connecting like a station transformer 2 to ACDB, DG set to ACDB. Depends upon the connected load, voltage, power factor, load current. Based on that, and what is the length? Based on that, we decide the cable size. So this is how. And from ACDB to all the outgoings, like I explained you now, main LT ACDB to switchyard ELDB. And these are all the feeders we are connecting across ACDB. These are all the feeders, and this is the connected load. Based on the connected load, based on the voltage, we'll figure out what is the full load current. Based on that, we just come out with the what cross-section area of the conductor is required for the connected load. So this is the importance of cable sizing calculation. Because why I'm telling, like cables in any system design, almost 30 to 35% of the system cost bear by cables. Okay, the first and foremost costliest equipment in the system will be the transformer, and the second costliest equipment in the system will be cables. So if you can optimize the cable, if you can optimize the cables properly, then you can save good amount of money and you can make your project economical. That is the most important equipment in electrical system. So here now based on the application, we have like a power cables, control cables, and instrumentation cables. Okay, so let us see like what do you mean by power cable in brief, and what is control cables, and where we use instrumentation cables. Okay, so generally your power cables are used. Power cables mostly used for the transmission. Transmission in the sense power transmission applications. So power feeders like three-phase or single phase, whatever it is. So for power cables are used for transmission, and the control cables are used for low voltage applications, control applications with a voltage of 110 volts and 220 volts. Controlling applications we use control cables. And instrumentation cables are used for communication, and PLC and SCADA applications we use instrumentation cables. Generally, instrumentation cables will be like a multi-pair cables, like a 10 pair, 20 pair, something like that. Okay, so let us understand more about power cables and control cable, because in an electrical system, we mostly use power cables and control cables. Instrumentation cables are used for the SCADA and PLC applications. As our topic is cable selection and sizing, we should understand most about power cables mostly. Okay, yes. So Here, let's understand about power cables first. Okay. So here, power cables generally we use for various applications. Power cables are used for high voltage. Generally, we use power cables for high voltage, medium voltage, and low voltage applications. Okay, just a minute, guys. Okay, yes. So power cables are used for the high voltage, medium voltage, and low voltage applications. And power cables also classified based on the conductor, type of conductor, and based on the insulation and based on armoring. Okay. If you look at based on the conductor, generally we use two types of conductors, like two materials we use as a conductors. One is like conductor is a medium which transmit the power, allows the flow of charge. So generally we use two conductors. One is like a aluminum conductor and a copper conductor. So guys, aluminum, your copper conductivity is double than aluminum. Okay, the point is depends upon the application. Okay, when generally in India mostly we go with aluminum conductor most of the applications to make the system economical. But if you look at like a Middle East or Gulf countries, they will go with a copper conductor. Okay, so it depends upon the financial constraints of the project. We generally go with. We'll just discuss like when we go with aluminum and where we go with the copper conductor. These are the two conductors we use based on the conductor and based on the insulation. Okay, insulation is the layer you could have seen. Insulation is a layer which protects the conductor from the mechanical damages you can see. Okay. My voice is clear to all of you? Am I clear? Rambabu? Yes, thank you. Yes, so insulation is the protective layer which avoids the conduction from the conductor. So we generally go with different insulation materials above the conductor. So generally we use three types of insulation. One is like a paper insulated lead covered and polyvinyl chloride and XLPE insulation. Generally in this among the three, mostly we use PVC and XLPE insulation mostly. So let us understand where we use, what is the application of PVC insulation, what is the application of XLPE, what are the advantages of going with the XLPE insulation over PVC, that we need to understand. Okay, so we'll see like advantages and the properties of XLPE over PVC when we use XLPE. Why should we go with XLPE and what are the advantages of XLPE over PVC? The first point is when you are going with XLPE insulation, it will provide high continuous current to the conductor. It is its ability to withstand higher operating temperature of 900 degrees centigrade, which enables much higher currents ratings than PVC. Because your PVC operating temperature will not be 900 degrees centigrade. Your PVC operating temperature will be somewhere around 120 degrees centigrade or 150 degrees centigrade like that. So that is the advantage like of going with XLPE insulation and high short circuit current XLPE, when you're going with XLPE insulation, the cable short circuit current will be higher. The maximum allowable conductor temperature during short circuit of almost 2500 degrees centigrade is considerably higher than the PVC cables. So that is one more advantage with the XLPE. And the next is emergency load capacity. Emergency load capacity in the sense, sometimes what happens, unplanned load may be added on the cable. So during that times, if you go with XLPE, it can bear that extra load. XLPE can be operated even at 1300 degrees, because generally in the cable selection and sizing, temperature is the criteria. Okay, because point is like when the temperature increases, your resistance increases. When the resistance increases, your conductivity will reduce. So that is, temperature is the most culprit for cable sizing. So that's where all these points will come into the picture. High emergency load capacity when you're going with XLPE. Okay. And low dielectric losses. XLPE cables have low dielectric loss angle. The dielectric losses are quadrically dependent on the voltage. If the Okay, moreover, these losses are occur continuously every charged cable, whether it is carries load or not. Okay, going with XLPE cable at higher voltage would result in considerable savings in cost. Okay, and charging currents. Okay, so these are the various advantage, easy laying and installation, because going with XLPE will makes you easy laying during the installation of the cable. So like that, there are here like a low weight and a small bending radius makes laying and installation of the cable. Because see, generally what happens when you're laying the cables, your bending radius should be very easy. Going with the XLPE will have a higher bending radius than PVC cables. That makes the installation of the cable becomes very easy. And of course, safety, because your XLPE mechanical strength is higher than PVC insulation. So obviously higher safety against mechanical damages and vibrations when you're going with XLPE compared to PVC. Okay, so that is about insulation around the conductor. Like we use PVC, XLPE and paper insulated material, isn't it? Three insulations we use: paper insulated, lead covered, polyvinyl chloride, and XLPE like a crosslink polyethylene. These are the three insulations we use around like above the conductor. Okay, the next is like based on armoring. Okay, I'll just show you how the armoring looks like. This is one polycab cable catalog. So in this cable here, like this is the conductor. This is the conductor, and around the conductor, this is XLPE insulation, and top of XLPE, this is PVC insulation. Okay, and this is armoring. This armoring is we have like two types of armors, like a flat armoring and a wide armoring. This is a flat armor. Mostly power cables, higher cross-section area of the cables will have flat armor. And the top of that, this is the sheathing, we call it as. And again, top of that, you have PVC outer insulation. So these are the various layers you have the cables. Like all these XLPE insulation, PVC, armoring, all these are provided for the conductor safety. Okay, so here you have like a cable. This is aluminum conductor cable. This is the conductor. Above that XLPE insulation, above that PVC, and the top of that you have flat armoring. Okay, and on top of that again you have PVC outer insulation. It is mentioned here. This is XLPE insulated heavy duty cable. Okay, this is 3.5 core cable, like a 650 by 1100 volts cable. And these are all the various cables like I told you, like a power cables, control cables, instrumentation cables, and all. Okay, so this is how a typical cable looks like. So now coming to the point, we have like two types of armoring we use for the cables. One is like a flat armored and wire armored. So this is the conductor. Okay, so here I have shown you one cable now. Like this is armoring called flat armored, and this in this cable, like this is a wire armored cable. You can see here, this is the one is a conductor. Top of that you have extruded semiconductor XLPE sheath. And 3 is XLPE insulation. 4 and guys, this session is recording. Okay, this will be available in the YouTube also in our channel later. Like whenever you wanted to connect through this session, you can go through our YouTube channel and you can listen this session. Nothing to worry. So if possible, you please note down the points whenever it is required. And so that is about flat armored and wire armor. Generally, you can ask me the questions are when we use flat armor and when we use wire armor. Generally, higher cross-sectional area of the conductors, higher cross-sectional area of the cables, generally we go with the flat armor. Okay, and the lower cross-sectional area of the cables, we prefer to go with the wire armored cables. Okay, and what are the standards to be followed? These are very important. Generally, guys, we follow for the cables, we follow IS and IEC standards. So IS stands for Indian standard, IEC stands for international standards. Like IEC stands for International Electrotechnical Commission. Okay, so here when it comes to the conductors, for the aluminum and copper conductors, we follow the standard is like IS 8130 and IS 3975. And for XLPE cables, we follow IS 7098, and PVC cables we follow 1554. These are the various, and PILC cables we go with IS 396. These are the IS standards we follow for the cable based on the conductor and based on the insulation. Okay, so now let us understand what are the different types of cables based on the number of cores. So generally we have single core cables. Based on the number of cores, I'm telling you, based on the number of cores, we have like a single core cable and 2-core. Feedback link will be given during the end of session, guys. So you please listen to the class and note down the points. We'll send you the feedback link. Nothing to worry. Okay. Yeah. So we have like a single core cable, 2-core, 3-core, 3.5 core, and 4-core, and multi-core cable. These are the different number of cores are available. So here now we need to understand what is the application, where we use single core cables, where we use 2-core cables, and for which application we use 3-core, 3.5 core, and 4-core, and multi-core. So mostly these multi-core cables are control cables. Multi-core cables are used as a control cables. And single core, 2-core, 3-core, 3.5 core, and 4-core is used as a power cables. Okay, guys, in this picture it is mentioned this is a copper conductor with a PVC outer insulation with a flat armored, again PVC outer insulation. Okay, so these are the various cables, aluminum and copper. So here you can see this. So far, this is like a aluminum conductor and XLPE insulation, PVC outer insulation. This is wire armoring and PVC outer insulation. So depends upon the application, we use various different types of conductors with different insulating materials and all. So now let us understand about the number of cores. These are all like a single core and three core, multi core. This is a single core cable, looks like this. Okay. Yes. So these are the multi core cables, and these are all control cables. I told you very clearly. Control cables shall be 1.1 kV grade PVC insulated with a stranded anneal. Like all control cables are insulated with a PVC outer insulation and annealed copper conductors having normal cross sectional area will be like 1 square mm, 1.5 square mm, 2.5, 4. Generally, we use up to 4 square mm, 6 square mm. We use control cables. Generally, we don't go with the 10 square mm and 16 square mm for control applications. Okay, 6 square mm mostly we use control cables. Okay, and I told you like control cables outer insulation will be PVC insulation. We don't use XLPE insulation for control cables because control cables are used only for the control applications, not the power applications. Okay, so that's the reason we generally use PVC outer insulation for control cables. So applications of control cables, where we use control cables, I told you control of outdoor circuit breaker. So generally what happens in the electrical system, see guys, actually electrical system is a interconnected system. Okay. So if you want to design any electrical system, you should understand about all the components, not only cable. If you just understand only cable and transformer, you cannot design the system. So you have to understand about all the electrical components like a breaker, current transformer, potential transformer, relays, and transformer selection and sizing, and cable selection and sizing, battery and battery charger. So you should understand about all the components. Then only you can design any electrical system. It could be a substation, or it could be a solar plant. It could be any electrical system, MEP or whatever the segment. So here we use control cables for control of outdoor circuit breaker, indoor switchgear, and control of HV and LV motors, and control of transformers. All control applications we use control cables. Very simple. Which is control cables are going to operate with 220 volts, 110 volts, AC and DC applications. Okay. So this is how your control cable, your panels, your indoor switchgear panels looks like. These are all the control cables you can see here. Okay, for control applications, we use control cables. Okay, these are all the various industrial applications. We use this cable for the internal wiring and all. So that is called control cables. Instrumentation cables already we mentioned. I told you like instrumentation cables are used only for the PLC and the SCADA applications. So your instrumentation cables also with a PVC insulated, and mostly your instrumentation cables are with a cross-sectional area of the conductor is 0.8 square mm cross-sectional area. And instrumentation cables are available like a 1 pair, 2 pair, 4, 6, 8, and 32 pair. You have different types of instrumentation cables. So now our intent is to understand about the power cable sizing calculations. So these are the various applications I told you. This is like a, if you visit any power plant, you will see this kind of control panels there where we use instrumentation cables, and all the breakers and all will be operated through SCADA mechanism. There we use instrumentation cables. Okay, so once you understand this, So guys, so far we understood about like a insulation power cables classification based on the insulation and based on the conductors and based on armored. So here now we need to understand the cable nomenclature. Generally, what happens is somewhere if you look at any single line diagrams in an industrial application, somewhere people mention like this, like a single run of 3.5 core, 70 square mm, uh, A2X FY cable. This is how people mention the cable. Somewhere people mention like AY FY. Somewhere people mention like a Y. So different nomenclatures will be given for the cables. Okay, so you should also understand, for example, if someone is mentioning like a to X Y cable, say what does it mean? So by looking at the cable nomenclature, you should understand what type of cable it is and what it represents. What is A, what is 2X, what is F, and what is Y. So that to understand that, you should understand the cable nomenclature. So generally, if the conductor is aluminum conductor, your cable is represented with A, and for PVC insulation is represented with Y, and XLPE will be 2X. You just note down this. This is very, very important. Okay, and generally we don't mention core, and number of runs will be like a number of cores. I told you like if it is like a single run of 4 core, C stands for core, and this is like a 300 square mm A2X FY cable. This is the nomenclature of the cable. So yeah, R stands for number of runs, and C stands for core, and F is steel strip flat armored. I have shown you we have two types of armorings. One is like a flat armoring and wire armored cables. Okay, so F stands for flat armored and W stands for wire armoring. W stands for yes, wire armored will be represented with W. And here, generally, if you look at flat armored with a non-magnetic material, generally, where we use this non-magnetic materials, we go with if your cable is a single core cable, if you are going with a single core cable, then your armoring material will be with a non-magnetic material. Okay, for multi-core cables, we go with a normal armoring only. Only for single core cables, armoring will be considered like a non-magnetic material. Okay? And this is if it is going with a metal screen, and these are all mostly like a double steel round wire armored. Generally, these double armored cables, flat armored or wire armored, are used for mining applications. If you are using the cables for the mining applications, generally we go with double armored cables because of you have to provide more higher mechanical strength in the mining segment. Okay, and PVC outer sheath. For PVC insulation, we represented with the Y, and PE is a polyethylene, that is PE, and this is conductive coating. Mostly, if to make you understand are what are the things you have to remember, I'll just tell you. Most frequently used terminologies here. Mostly we use here like what is a conductor. For example, if your application is, let me take a single run 3 core 150 square mm copper conductor. Let's first I'll take aluminum only because I don't want to confuse you. Okay, this is aluminum conductor. And XLPE inner insulation and flat armored and PVC outer insulation. This is my cable description. For this cable, for example, all this description shall be represented with a nomenclature. So aluminum conductor is represented with A. Aluminum conductor with XLPE inner insulation. On top of aluminum conductor, XLPE is represented with 2x. And after that, your armoring is like a flat armoring. So your flat armoring represented with the F, flat armored. And top of armoring again, it will be with the PVC outer insulation, will be Y. So this is what my meaning of A2X FY cable. A stands for aluminum conductor, 2X stands for XLPE inner insulation, F stands for flat armored, and Y stands for PVC outer insulation. Okay, so for example, if your application is your conductor, we are not using like aluminum conductor. I'm just using copper conductor, for example. If I'm using a copper conductor, then how to represent the nomenclature of the cable? Okay, in that case, what we do, we just remove A. If it is a copper conductor with XLPE inner insulation, armored with the PVC outer insulation is defined with the 2X FY cable. If A is there, that is for aluminum. If A is not there, that cable is a copper cable. Okay, most frequently we use A, Y, 2X and flat armoring and wire armoring. And FA is for non-magnetic material, and this is for wire armoring with a non-magnetic material. This is used for single core cables. This is how we define the nomenclature of cable. Guys, is it clear? Any doubts? Yes, there is runs in a sense. I told you. I'll just explain you. Here, there are some. I have shown you the catalog, right? I'll just explain you what do you mean by runs. This is, see here, runs in the sense all together, this is one run. Here you will see, right? This is one run. RYB all together, we call it as a one run. This is one run, 3 core cable. This is single run, 3 core cable. This is one run. Okay, 3 core cable. And sometimes this is single core cable. One run, altogether one cable is one run. Okay, whether it is 3 core cable or single core cable or 4 core cable, it doesn't matter. Okay, the voltage drop of that and all we discussed, don't worry. Okay. Yes, thank you. Here, now we need to Yes, after the cable nomenclature, here it is mentioned very clearly how to give the cable nomenclature. First, a cable shall be represented with a number of runs first. Okay, number of runs in the sense I told you now here. You just look into this like 2 runs of number of cores. Let me take 3 core. Size of the conductor. What is the size of? Depends upon the current carrying capacity. Let me take 150 square mm is the size of the conductor, and the type of conductor. Type of conductor is, let me take aluminum conductor with the inner insulation is like a XLPE insulation, and type of armoring is like a flat armored, and the next is outer insulation is like a PVC outer. It depends upon, like, it's like every cable will not be same like this. Okay, depends upon the requirement. We'll go with like which should be the inner insulation, which should be the outer insulation, and whether it is a flat armored or wire armored. Sometimes we go with the cables without armoring. Wherever if there is no mechanical protection to the cable, then generally without armoring also we go. If there is no flat armoring, then your nomenclature will be like A to X Y cable. There is no F because the flat armor, we are not using any flat armorings. This is how we represent cables. Okay, this is a cable nomenclature. Okay, 3 runs of single core. See, before going to understand the sizing calculation and all, these are the things very important to that we'll discuss on the LSH and FRLS and all. Okay. 3 runs of single core 300 square mm conductor made of aluminum with a PVC. That's what I explained now. Okay, and here 3 runs of single core 300 square mm AY-FY cable. So what do you mean by this? 3 runs is like a three cable. 3 runs is 3 cables of single core. Like a single core means each phase 1 core is connected. R, Y, B, and 300 square mm is the conductor size. AY-FY is aluminum conductor with a PVC outer insulation with a flat armoring and PVC, like a PVC inner insulation and PVC outer insulation. This here. Okay, here it is mentioned 3 runs of single core 300 square mm conductor made of aluminum with the PVC inner insulation, flat armored, and PVC outer insulation. This is how we give the nomenclature of the cable. Two runs and 3 runs in the sense very simple, Andy. Actually, if you are, I'll just show you that. In the single run of cable, if you have like 3 runs, 3 core, this is 3 core. Okay, and one more run of cable, you have 3 conductors. So this is 1 run and this is 1 run. So what we do here, let me take this is RYB and here also RYB. So when you are connecting like this R and this R will be connected at one place. This Y and this Y, and this B and this B. So each phase we are connecting 2 runs. This is how it will be in a practical scenario. Okay. So it depends upon the current carrying capacity. Generally, we decide how many number of runs shall be connected per phase. Okay. So once you understand about the cable, so now we need to know how to do the cable sizing calculation, or what are the parameters decide cable size. Okay, so this is a major important thing which we are looking for. So major parameters deciding the cable size will be here. First and foremost point is the current carrying capacity of the cable. and your cable size. Cable sizing is nothing but conductor sizing. You should not get confused. Cable is nothing but conductor with insulation. Here you are trying to find the cross-sectional area of the conductor based on the current carrying capacity. Okay, so whatever the cable size depends on these three parameters. One is current carrying capacity and voltage drop and a short circuit withstand capacity. These are the three major parameters decides cable size. Okay, so the point here is how to decide the conductor size based on the current carrying capacity and what are the derating factors we have to consider, and how to calculate the voltage drop and what formulas we use to calculate the voltage drop. And in the cable sizing calculation, you have like two things. One is like a LV cable sizing and HT cable size. So generally for LV cable sizing will be decided based on only current carrying capacity and voltage drop. Whereas coming to HT cable size, we also consider short circuit withstanding capacity as a major parameter. Because when your voltage level increases, your fault level increases and your current carrying capacity will decrease. So this cable sizing calculation shall be divided into two parts: LT cable sizing calculation and HT cable sizing calculation. Okay, so let us see now like what are the parameters decides LT cable sizing and what parameters decide HT. Parameters for LT, in the LT also again you have different parameters like incoming. This, if for example, if this is your SLD like this, so these are all the outgoing feeders like this. So what we do, this is one cable, this is called incoming cable, and from here whatever the cable you are connecting to the motor or whatever the application, so this cable is a outgoing cable. Okay, so for what parameters you should consider for outgoing cables and what parameters you should consider for incoming cables, that also differs, because in the outgoing cables mostly what we do is we use like a MCCB or SDFU switch. MCCB stands for molded case circuit breaker. SDFU stands for switch disconnector fuse unit. So what happens if there is any fault occurs here? If there is any fault occurs here, this MCCB or SDFU operates instantaneously. Means the operating time of the breaker or switch is less than 10 milliseconds. So for this reason, what we do, whatever the outgoing cables, we don't consider this cable size based on short circuit withstand capacity. Outgoing cables are going to decide based on current carrying capacity and voltage drop. Okay, so like we have to consider various parameters for LT outgoing cables. The cable size is going to decide based on the current carrying capacity and voltage drop. Okay, I told you here very clearly. As the outgoing feeders are protected by fuse, MCB, MCCB. MCB stands for molded case circuit breaker. MCB stands for miniature circuit breaker, and MCCB stands for molded case circuit breaker, which provides instantaneous protection. Okay, means instantaneous protection in the sense the operating time is less than 10 milliseconds. Hence, the short circuit withstand capacity is not considered for LT outgoing cable. This is a very important point in cable sizing calculation. So these are the parameters considered for LT outgoing cable. And now we have to know how to decide the current carrying capacity and how to calculate what are the derating factors we have to consider and how to calculate the voltage drop, that and all will discuss tomorrow session. So in the tomorrow session, we have to understand all the calculation, what are the formulas are used and what are the derating factors shall be considered, how to decide the derating factors by taking the cable catalogs and all. We'll see LT cable sizing calculation and HT cable sizing calculation. We'll do tomorrow. Today, this is enough. Okay. So already I think feedback form is given in your chat box, guys. So you please give your valuable feedback. Your feedback matters a lot for us. Okay. And based on your feedback, we'll correct if we want to improve or enhance any things here. And if you have any doubts, you can ask me now. Thank you so much and for your great patience and connection. Okay. So guys, if you have any doubts, you can ask me now.
So we had a question of FRLS and
Yes, actually the FRLS is like a fire retardant low smoke cable. It's like generally we use these FRLS cables are used mostly for the MEP apply, like shopping malls and wherever indoor applications. If you want to like a fireproof cables, then generally we prefer to go with FRLS cables. And what else? What is other? FRLS and the next one is FRLS is fire retardant low smoke, means when the cable is catching fire, so it will not give you the smoke. Any other questions?
So you can stop your screen sharing. Guys, tomorrow also we have our workshop day 2 session.
Yes,
So
actually
please do
tomorrow
connect
is the
tomorrow
major session,
and
very important session because major content will be covered tomorrow session. So I'm expecting all of you should be um, in the session and please available tomorrow session with the calculators.
yeah, we would like to make it an interactive session, guys. So we request
Exactly.
you all to have your calcs and be prepared. And you will learn one major aspect of cable sizing, which is prime thing in industry selection and sizing, guys, in terms of system design. Any other questions, you guys can unmute and speak up. And if you don't have any questions, we would like to end the session now. And please do connect tomorrow. Guys, we have shared our feedback link in the chat box. We request you all to give your feedback to get your certificate of your day 1. And you will also get your certificate for tomorrow also as you connect it. Please check your spam as well as your Gmails as soon as you fill up the form. Okay. If you haven't received, our team will be available to give you, we will be answering your queries on Monday for sure if you have anything. And any more questions, guys?
Thank you all. See you tomorrow. Thank you so much.
Thank you, guys. Thank you. So please do give your feedback link. As mentioned in the chat box, we do have our new batch because we had Pawan Kumar Rajat asking for an SLD designing. So we have our new batch starting this month on 20th March, guys. If you are interested to join with us, please do register with the given link on the chat box, or you can call upon the given numbers to us if you want to join our course, guys. Thank you so much.
Yeah, Srilata is asking about solar related cable sizing. Actually, the point is
We will cover the session as another webinar, Srilata.
yeah,
And if you
because
really wanted to attend or to learn that, please do join our course. That might help you in a
yeah,
better
exactly
way.
because we cannot cover every aspect in this session. Just this session is to give a glimpse on cable sizing in a generic industrial applications. So if you want any specific or if you want to learn about all the system design, then you have to join with our electrical design course. That would help you to get a complete knowledge along with a job. Thank you.
Srinivas Garu, you said you need VLSI. So this respective course is purely for electrical students only. Where we are talking about VLSI, we might start our new batch on VLSI sooner. So once we have got some information regarding the batch, we will let you know, Andy. Thank you so much for your patience. Thank you guys. Thanks for your participation, and we hope you enjoyed our session of day 1. Tomorrow we'll come back to you on day 2 session with a detailed cable selection and sizing, guys. Thanks. We'll keep awaiting for the next session. Thank you. Good day.